AJ113 Cruise Control by Jaguar Rover Triumph Inc. A training module revived by Jaguar Clubs of North America JCNA and Coventry Foundation. Please see www.jcna.com and www.coventryfoundation.org. Additional material by David Boger, everydayxj.com. Any supplemental diagrams or information are included at the end of the video, where you can halt and screen print if you wish. Please note that these materials were recovered from audio tapes and slides stored for more than 40 years, and the quality has suffered on some tapes, and we apologize.
Jaguar Rover Triumph Incorporated presents Cruise Control. Both 1980 Series 3 Jaguar and Rover 3500 cars now have cruise control as standard equipment. The systems in both cars operate essentially the same. However, there are detailed differences and there is no parts interchangeability. Today, we'll explain system operation and troubleshooting. The troubleshooting procedures are detailed on the reference cards accompanying this program. Let's start with the Jaguar Cruise Control. The Jaguar system uses engine manifold vacuum to operate a servo, which positions the throttle linkage to maintain a selected speed. The servo is modulated by an electronic control unit, which in turn is activated by the driver's controls, sensing devices, and safety devices. The master switch, located on the center console, controls the current feed to the ECU, electronic control unit. The magnetic pickup, mounted at the rear of the drive shaft, senses road speed. The cruise control inhibit switch, mounted at the base of the gear selector lever, disengages the system when the transmission is shifted to any gear other than drive. The set switch on the steering column stalk will, when depressed, bring the system into operation. The system will maintain the road speed at which the set switch was activated. The ECU, electronic control unit, mounted under the right side dash panel, controls the operation of the system. Current is fed to the servo solenoids, modulating the vacuum in the unit to position the throttle as required to maintain the selected road speed. A memory circuit in the ECU is activated when the master control switch is moved to resume. The memory is canceled when the master switch is moved to off. Another circuit in the ECU prevents the system from operating at speeds below 25 miles per hour. When the brakes are activated, current is fed to the ECU from the stop lamp switch located to the right of the brake pedal. This causes the servo vacuum to be dumped, thereby closing the throttle. The brake-operated switch on the left side is a safety backup to the stop lamp switch. The last component in the system is the servo assembly. It contains two solenoid valves which control the amount of vacuum allowed into the servo. The control solenoid allows vacuum into the servo, while the dump solenoid allows air into the servo. In operation, both solenoids modulate so that the vacuum in the servo is constantly varying to accurately maintain road speed. A series of simple checks can be performed to accurately diagnose a fault in the system. An ohm meter or continuity tester and a voltmeter or test light are all that's required to do the job. Initial checks are as follows. Examine fuses 11 and 12 and ensure current is being fed to the circuit. Examine the electrical connections at the ECU. Be sure all the pins are tight and that the two connector plugs are securely connected. Examine the vacuum hose from the intake manifold to the servo and the servo bellows for leakage. Replace as necessary. Examine the servo cable connection and linkage at the throttle pedal for wear or binding. and examine the magnetic pickup unit at the rear axle. Ensure both magnets are clean and tight, and that the gap between the magnets and the pickup is approximately 9/32 of an inch. Remember, the vehicle speed must be over 25 miles per hour for the system to operate. After completing the initial checks, locate the ECU under the right side dash panel and turn the ignition switch on, and the cruise control master switch off. Then check for voltage at the 9-pin connector. No voltage should be evident on any of the pins. Note that the color coding of the ECU harness changes at the ECU connectors. In the following checks, we will quote the vehicle harness color coding only. Reconnect the components after each check. Turn the master control switch on and check for voltage at the 2 yellow-orange pins at the ECU connector. If no voltage is present, the master switch is defective, or an open circuit exists between fuse 12 and the ECU. Depress the brake pedal and check for voltage at the green-purple pin. If no voltage is present, the stop lamp switch is defective, or an open circuit exists between fuse 11 and the ECU. Switch off the ignition and locate the brake-operated switch to the left of the brake pedal. Disconnect the yellow-white leads and check the switch for continuity. The switch is normally closed, opening as the brake pedal is depressed. If continuity is present, the switch is OK. Remove the center console insert panel and locate the inhibit switch to the right front of the selector quadrant. Disconnect the black and yellow-purple leads and check the switch for continuity. The switch is normally open, closing when the gear selector is moved to drive. If no continuity is present when in drive, the switch is defective or in need of adjustment. Locate the master control switch harness connector at the left front of the center console under the kick panel. Disconnect the 4-pin plug. With the master switch off, there should be no continuity through the switch. With the master switch on, there should be continuity between the yellow-orange and the light green-yellow pins. No other pins should have continuity. With the switch held to resume, there should be continuity between the black and black slate pins. The yellow-orange and light green-yellow pins should also have continuity. If continuity is not present as described, the switch is defective. Now disconnect the magnetic pickup 2-pin plug at the ECU and check for continuity. There should be continuity between the white and shield pins. If there is no continuity, check the harness connection at the right forward edge of the center console. There are 2 bullet connectors, white to white and shield to red. Recheck for continuity. If there is still no continuity, remove the rear seat cushion and check the harness connection on the left side where the magnetic pickup leads enter the car. And check for continuity between the 2 pickup sensor pins. Repair the harness or replace the sensor as necessary. Extreme caution must be used to prevent engine over-revving in the next test. Connect the servo black lead to ground. Then start the engine and momentarily use battery voltage to energize the yellow-black lead to the servo. The engine should speed up immediately. If it does not, the servo or accelerator linkage is suspect. The last item to check in the Jaguar system is the set switch. Disconnect the single white to black-pink connector under the steering column and check for continuity. With the switch depressed, there should be continuity to ground on the white wire. If no continuity is present, the set switch is defective. This completes the operation and troubleshooting of the Jaguar cruise control system. Next, let's look at the Rover cruise control, starting with the system operation. As we said earlier, the operation of both systems is essentially the same. Three components differ in the Rover. The Rover's column-mounted engagement switch combines the functions of both the master control and set switches in the Jaguar. A disengagement switch mounted on either the clutch pedal in manual transmission cars or on the brake pedal in automatic transmission cars dumps the servo vacuum when the pedal is activated. It also signals the ECU. The deceleration switch mounted in the engine compartment on the left side is a safety backup for the disengagement switch. The remaining components operate as described for the Jaguar. The magnetic pickup is mounted on the body at the gearbox rear flange. The ECU is located in the left glove box, and the servo is located above the alternator. The Rover system operates at a minimum speed of 30 miles per hour. Fault diagnosis is accomplished by performing a series of checks with a special electronic tester, part number BLT 5011. When using the tester, please refer to the blue copy, form number 1938, that accompanies the tester. The tester is available from Jaguar Rover Triumph Incorporated. Also required is a hand vacuum tester. The electronic tester replaces the ECU in the system for diagnostic purposes. Release the ECU connector by inserting a small screwdriver or rod into the terminal release hole of the ECU. Press down while carefully pulling on the wiring harness connector. Caution, pull on the connector, not the harness. Connect the tester to the ECU harness and start the checks. 5 simple tests will accurately locate faults in the system. Refer to the reference card for the causes of incorrect responses to each test. The first is a check of the power source. Turn the ignition off and the engagement switch on, and check the tester lights. All the tester lights should be off. The second test checks the system's electrical continuity. Turn the ignition on and the engagement switch on. Again, check the tester lights. Lights 1, 2, 3, and 4 should be lit. 5 and 6 should be out. Test number 3 checks the servo continuity. Caution, be sure the engine is off during this test to prevent over-revving. Turn the ignition switch on and the engagement switch on. Push and hold the set speed button. Then check the tester lights. Lights 2, 3, 4, 5, and 6 should be lit. 1 should be out. Test 4 checks the disengagement and deceleration switch continuity. With the ignition switch and engagement switch on, depress and hold the brake pedal. Then check the tester lights. Lights 1, 2, and 4 should be lit. 3, 5, and 6 should be out. The final test checks the resume position of the engagement switch. Caution, again, be sure the engine is off during this test to prevent over-revving. With the ignition switch on and the engagement switch on, slide and hold the on-off switch to resume. Check the tester lights. All the tester lights should be lit. A simple test using a hand vacuum pump will check the mechanical operation of the disengagement switch. Remove the hose from the switch. Connect the hand vacuum pump and apply vacuum to the switch. When either pedal is depressed, the vacuum should dump. If not, the switch is defective. We have illustrated here the operation and troubleshooting of Jaguar and Rover cruise control systems. The reference cards accompanying this program contain system diagrams, schematics, and troubleshooting procedures for both systems. This completes cruise control, a part of the continuing Performance Masters service training system. Participate in the Performance Masters program by taking the performance test. Your service manager has the details.
Revived by Jaguar Clubs of North America, JCNA and Coventry Foundation. Please note, all special tools shown here, apart from the Sun Workstation, are available under the JCNA, Coventry Foundation Members Tool Loan Program. Please see www.jcna.com and coventryfoundation.org. Thank you.